everybody's here. Okay. Great, welcome back from the break. I guess we will go ahead and get the final session started. Before we get started, I just wanted to... Before we get started, I just wanted to start by thanking all of you for giving really great talks and for great discussions and posters. It's always impressive to me just the really broad scope of science that both departments cover. And I want to start by giving you all a round of applause. Someone actually asked me, are you and Frank giving this talk because we've been so disappointed in previous talks from the group? And I want to clarify that and say absolutely not. We totally understand that for many of us, public speaking doesn't come easily, and it's something that throughout your careers, you'll continue to self-evaluate and to look for feedback. Frank and I do this all the time after talks. We text each other, we talk about what went wrong. So I don't think you ever reach a point in your career where you think, I give great talks. Like, that just doesn't happen unless you have a complete inability to self-evaluate. These people exist, but you won't get better if you don't. And so, as Frank and I thought about how to give this talk, we did realize there's a very human element to it, in that we all kind of know a good or bad talk when we see one. And rather than preach to you about how to give a talk, we thought it would be most helpful to actually start with an example talk that we can then later together discuss. I'll comment on it first and give you some of my tips. But I'd ask, during this example talk that Frank has graciously agreed to give, that you maybe you can take some notes on paper, or on your phone, mental notes, photographs if you'd like. And then afterwards, I will try to break down some important points that I saw from the talk, and then we'll bring it together for all of us to discuss. So I'd like to introduce Professor Frank Neza, who has agreed to give a 5-minute flash talk. Frank, the floor is yours.
Do we have the green one?
Yeah, sure.
Okay, Okay. Yeah, the other day I was talking to Susie, and she said it's okay, but then I also, her husband, Werner Knettenbrech, actually, then he got a PhD in physics from the University of Braunschweig, or maybe it was computer science, and Werner didn't like it, so I'm not going to tell you that joke now. Then I wanted to tell you. Okay. I first wanted to congratulate the organizers for having me. I know that's quite a catch, and I always give these amazing talks, and it's actually I think the biggest, most wonderful talks in the history of science, and we also have the biggest crowds, and it's and there are hundreds of thousands of people out there waiting to get in, and then it's all right, and I know it's a very short talk, very, very short talk, and so that is also what I tell my students. It's really important to be laser focused on the message. It's really important to be absolutely concise with respect to the message, and not go off on random tangents, right? That reminds me, to that point, the other day, my wife and I, we were driving down to Heidelberg, no, Erlangen, it was Heidelberg, Erlangen, I don't remember, but we were just like on the Autobahn, and then, you know, like she said, you're not going to make it, and then I said, well, just you wait, you're going to make it, and so we arrived at the hotel like 2 minutes before like the restaurant closed, and said, you made a point landing, and then so I thought that was really funny, like point and point, you get it, that was actually hilarious, and yeah, okay, all right. So I show you some of our very recent results here, and the subject I'm going to cover today will be the world record-breaking novel ACP37 outcompeting even CP96G across lamb. And if you don't know what that means, then that makes two of us, but maybe like we figure it out by the end of that talk, then I mean, people have been talking about maybe like 45, 30, then it's like, I don't know, maybe even like LAM or GAN, but like we're doing CP96G across lamb and be better than it. And I'm going to show you how. And, but I think like before, I guess you know that I recently got appointed to be the founding director of the Center of Game-Changing Revolutionary Innovations, and that's actually a thing that's funded by 18 different European countries. And then as we asked J.D. Vance like to write the foreword to our statues, but I guess he was busy. He had something in like Springfield, Ohio, I guess, with cats and dogs or something. I don't really know what it was, but anyway. So now get you started. It's really like, let's take a look at the big picture, and that's the world, right? I mean, the world, and the world really has big problems. I mean, think about like cancer, AIDS, Alzheimer's, COVID, even athlete's foot, right? And then there's green energy, there's nuclear warfare, there's world peace, there's hunger, there's natural disaster, and the worst of all, it's like single-sex, you know? And how are we going to address that? That is the big question. And everything starts, of course, with like thinking deeply about the problem at hand. And I'm going to show you how all of this like goes away, and then it's right. And so the first thing is to like really carefully look into the literature, and that is what we did. And of course, we need solutions, not words. Mark my words, solutions, not words. All right, and so let's take a look into the literature, and then so you see like there is some really groundbreaking work like from and I want to really highlight that paper here from like 1924 that is like where that all figured out, and so we came up with something absolutely extraordinary. Then it was a combined experimental and theoretical thing. And like, I mean, like, look at it. It was just like incredible. Then it's okay, and then so you see, like, there's a straight line, and it matches the data perfectly. Then but it's not just a straight line. I mean, our straight lines are the straightest lines in the history of science, and it's like, yeah, you know, I mean, they're like 80%, 90%, 95%, 120% straight lines. And how am I doing in time?
You've used up all of your time.
Okay, then I keep going with the second part. All right. And so we thought, like, that is absolutely incredible. Like, but how can we take it a step further? And now we can turn it around. And so you see, yeah. See, then how am I doing in time?
You've used up all of your time.
All right. Okay. Good. So, but now in the second part, it's going to be even more amazing. And then, but look, if you can do this, look what I can do too. And it goes on and on and on. See, the sky is the limit, and that is what I'm talking about. Really, the sky is the limit if you do it carefully. And so I want to take you on a little journey and like show you how we arrived there. So we're moving towards the big goals here. How am I doing in time?
You really need to wrap it up
Okay. Yeah. All right. Just like 13 or 14 more slides, right? All right. So here we're going. So Monday, got up but did not feel like working. Okay. But like Tuesday didn't get up at all, and then Wednesday got into work and started an experiment, but the machine was broken. I had to cancel it, so maybe it goes up back soon, and then I can do that experiment. But on Thursday, I actually start again and added 2 or 3 aliquots to the stock solution, and then I'm not exactly sure what happened, but like something probably happened, and then on Friday, I was just too frustrated to do anymore, so I decided to start again next week. But then it was my mom's birthday, and so on Monday, I didn't feel like going back to work. And then on Tuesday, I repeated what like I did last week, and it looked similar, but also a bit different. How am I doing in time?
Still completely out of time.
Okay, good. Then I keep going then. So on Wednesday, I tried a different solvent, but I guess I forgot to check the pH, so that has to be repeated. And then, so maybe it's reproducible, but there's more work to do. And but here's the bottom line, right? The bottom line here, right, is to do those experiments, right, and spend a lot of time with the analysis, and then you arrive at these groundbreaking, revolutionary, game-changing, and world-changing solutions. And to come up on that, so now here's like the latest result that we're having, and I've highlighted it here in yellow on white, then is that as how, and that should really drive it. How am I doing in time then? Still completely out of time. Okay, good. Then we can keep going. And then, so it's really important to understand how to dig deep into the problem. As you see here, like on all of these like labelings here, then is so that it's clear that you have to make things really clear. And so that is the only question that remains now. Then is, and like we're hopefully get to that really soon. Then is, yeah, okay. All right, so here's my summary of my talk, and how am I doing in time? Okay, I just keep going. Okay, all right, okay. So what I really wanted to say here, there are things to consider, right? And so there are various ways to consider it along various pathways, right? And so there are different things and alternative facts. Let that sink in, please, right? There are the things, and then there are the alternative facts. But like the absolute key here is that like it's got to bring clarity, right? So it's got to bring clarity into the problem, and so that may lead to either the same outcome or a different outcome. That is the key here, right? That is, if you don't take anything home from the talk other than that, then please here stay with my punchline. Then is so sometimes things are one way and sometimes they can be quite different. All right, okay. I hope that was amazing. I can just like please. I only have like my acknowledgements. Okay. So here's my acknowledgement and what I absolutely have to do that. So I wanted to thank my cat for being so cute all the time. Then it's just like amazing. And also, I mean, the Amazon delivery guy for never missing a package. That always makes my day, like really. And I also should really give credit to Netflix for being so boring that like I'm really inspired to work. And oh yeah, mom and dad for the apple pie. That's just incredible, like at apple pie. And then yeah, there's Jill and Joe and Amy and Fred for being such great company in the lab. But of course, my mom might bring by. Okay, like let's not talk about that. But then I also thank all the PhD students and postdocs of my collaborators, and President Kramer for paying me a salary. And finally, I guess I also have to, because I wanted to mention my boss and all the nice people in the group. And then finally, thank you so much for your attention. And that is all I have for you today. Then.
Unfortunately, there's no time for questions. So I just ask you to please take a seat, and we'll continue with the rest of the meeting. So obviously, Frank's talk was meant to be an extreme exaggeration, but probably if you sort of dial it down, there are aspects that he hit on that many of us have done maybe in far more subtle ways. And so what we wanted to do was to basically take his talk as sort of a basis and really break it down in terms of what to think about when you actually are preparing for a talk. And one of the things that Frank absolutely didn't do was to decide on the story he had to tell, right? And of course, this comes at the level of talk preparation, that you clearly define the goals. And that, of course, starts already with the title that you submit for your talk. If you're going to a conference, it starts with the abstract. And that title should sum up and give the key message that you'd like to communicate. It should make people actually want to attend your talk. Now, Frank's talk title managed to be simultaneously and intentionally arrogant, offensive, and opaque, right? And this is what we don't want to do. He started with pointing out his work as world record-breaking, that it was out-competing, and then it had acronyms that we absolutely don't understand, right? So it's kind of a reminder that your talk, even though it's a scientific talk, the title should be actually independently readable. And so an alternative title would be Comparison of the State-of-the-Art Protocols to Investigate the Reactivity of Human Papillomavirus Protein. And that is ACP37. Now, we might not still all understand that, but it gives us a place to start working. And it seems over the top, but the reality is for all of us, computational chemists, spectroscopists, biochemists, we live in worlds of our own acronyms. And we start to think that everybody knows what we're talking about, and they don't. And so when already at the level of your title, you've alienated a fraction of your audience, it's not off to a good start, right? Okay, then you need to actually tell your story. And of course, again, Frank took this as an over-the-top bad example. And it seems obvious to say that the story you tell needs to be clearly organized, right? And that there needs to be an introduction that puts your science into a broad context. But we always have to be careful with how we define the big picture. And so again, Frank's science spanned COVID and single socks, all pressing problems in the world. But let's be honest, we've all been at a talk that talks about global energy challenges and follows it with a cobalt catalyst that does substoichiometric activation of an incredibly weak bond. You set up your audience for an expectation that you don't deliver on. That can be really disappointing. And science, of course, we're in it because we want to have fundamental understanding. So yes, place it in a broader context, but don't make it far-fetched, because if this is sort of the visuals that it's conjuring up for the audience, it's not going to work. The other thing I wanted to really emphasize is take the time to define the methodology that you're using and tailor it to your actual audience, right? And so at our department seminars, you're always speaking to a very mixed group, right? There are people here with more theoretical backgrounds, more experimental backgrounds, and even among the experimentalists, we span a pretty wide range. So take the time. We're all experts in our own methods. But so often, I hear so many of you say, oh, I don't want to present it because people have seen that before, or they've heard me talk about that before. I hate to break it to you, but so many people don't remember what you presented last department symposium. And it's about telling a complete story. It's not about saying, every time I present something, everything needs to be new. No, just tell your story, your complete story, and allow that story to actually evolve. Now, your results, they should be clearly presented. Frank gave a very strange example of a lab book I hope to never see in my own group. Don't read us your lab notebook, right? You have to streamline and distill the information. Whether it's a 20-minute talk or a 1-hour plenary, nobody needs the excruciating details. That said, don't go the other way. Some groups, luckily, I don't see this here at all, but there are other groups that will remain nameless, who never show data, right? They only show conclusions. And that's also not convincing, right? So as scientists, streamline, distill, and show the data that you need to show to support or refute a hypothesis. And then, of course, you need a clear conclusion, preferably not a concussion, that is, again, understandable to the whole audience. So when you think about your talk, especially for this audience, make sure that at least the first few minutes and the last few minutes are for everybody in the room. The talk can escalate, it can get more complicated. There could be something towards the middle end that is really for the specialist, but at the end, bring it back and invite everyone back to your talk, right? That's what we really strive to do when we're telling our story. The other, of course, is to prepare in advance. We all have to do this. We all have to take the time to practice talks. I have to applaud you that nobody's talk was too long this time, so I think you guys did a really great job in the preparation. I think sometimes there's a temptation that you want to get as much as you can into your talk and that you're going to fix it by rushing. If that's the situation you're in, it's better to actually cut from your talk. One thing that I know my group hears me say a lot is that being on time is a sign of respect for your audience. So Frank was really disrespectful, and nobody else in either department did that. So thank you all for showing respect to each other and allowing time for questions. Some more general comments, just as you're streamlining your talk, it doesn't mean you need to delete things entirely. You can move things to the supporting information that can be used for discussion later. The other point is be careful with the animations. Nobody needs your spectra spinning around, right? But you can use them when they bring clarity. It's very hard for most of us to look at 6 spectra laid on top of each other. And if you use the animations to build, to help people see better, that's a useful way to use an animation. Of course, a big one that was kind of a joke in Frank's talk, but it's a reality in many talks. Check for typos. I picked this one from a school crossing in the US, which is one you probably don't want to send your kids to that school, right? But it becomes incredibly distracting in a talk when someone has a template where a word is spelled wrong during the entire talk. So I once attended someone's talk where the word results was, unfortunately, the U and L was flipped. You can spell that in your head. And it was on every single slide. And it was distracting. It is a message to also to keep your graphics simple, but not so simple that you actually remove the axes. We actually saw some of this even in the department symposium. If people don't know what your axes are, you haven't communicated what you wanted to communicate with that figure. Choose colors that everyone can see. Pale yellow on white, pale pink on white. These are challenging colors for most of us to see. And also, I know a tip from my own group, there are palettes that are also colorblind friendly, so you can consider that. During the presentation, of course, Frank started this way, right? Talking to the corner, to his screen. It's very easy for us to fall into that habit, right? But when you make eye contact with your audience, you connect to them in a way that they're far less likely to start falling asleep, right? And I think it's as soon as you become less engaged with your audience, the more likely your audience is going to figure out something else to do. So show them that you're actually interested in them. Of course, speak clearly, enunciate, be loud enough to be heard. It doesn't mean you need to shout, but for some of you that are a bit more soft-spoken, it is something that you just need to train projecting your voice, to train actually enunciating. Apparently there are YouTube videos on how to do this, so if you've got mumbling issues, apparently there's exercises for this. Importantly, convey your enthusiasm. Most of you are here because you're excited about doing science. Maybe less excited about having to present it, but if you genuinely are enjoying your science, let that shine through. And I think that already makes for a very good presentation. Use your laser pointer sparingly. If you have good graphics, you don't need to use it as often. And a lot of us, when we get nervous, the hands start to shake. I'll never forget my first big talk at an international conference. I got somehow stuffed between really big name people, and suddenly I had a crowd of like 800 people, and it was my first talk at a meeting this size, and I was completely doing the laser light show that I have like here. It was just, and the thing actually that comforted me so much was a very big name in my field who seemed like he was never nervous in his life. He came up to me afterwards and gave me a tip, and he said, what he does when he gets nervous is he puts one arm under and he braces his arm. And then I noticed he actually did that in his talks. And it had never dawned on me that this person might actually ever be nervous. But it's just a very human attribute. Use humor if it works for you. And I'll be honest, we're not all funny, right? Like, it's just, I put a little worse than dad jokes up there, but nothing is worse than giving a talk with one of those planned jokes that just totally bombs. It will throw you off. So if that's you, just leave it out. And eventually, maybe you get more comfortable with the idea. I'll never forget a former member of Frank's group who inserted a joke into her talk, again at an international meeting. And I think it was someone who had a personality who wouldn't normally tell jokes and forgot that the joke was in there. And when the joke came up, it was one of, a famous Frank quote bubble. It scared her. So she just jumped. It turned out to be a lot funnier than the actual joke. You have to, you be you. Like, do what works for you, because for a lot of us, it just doesn't feel natural. Referencing and acknowledgements. This is a big one, especially for scientists. Please make sure your slides are properly referenced. If you're showing someone else's data, my own personal preference is show the complete reference, preferably with all the authors. I know it doesn't always fit. You can shorten it to the first author et al. If it's a large body of work, apparently all by the same author, you can refer to work by NASA and coworkers, right? So the lead author and coworkers is also appropriate if you're referring to a large body of work. In general, my preference would be to try to list all of the primary references, and again, try to give complete author lists. And also really work to give credit to the broader community and to your own research group, but always try to keep it in balance, right? It's rare that you're the only person or only group doing something, right? It goes without saying, but acknowledge the people who've contributed, and I mean this not just at the start or the end of your talk, but throughout the talk in the way you actually present it. Science is very much a team effort, and most of the time, the appropriate pronoun to or the appropriate word to actually use is we and not I, because it's not that often that you did something completely alone. In terms of the acknowledgements at the end of your talk, keep it concise, but your cat and the Amazon delivery person will forgive you, Frank, if you had left them out. But keep it in balance. I mean, I know, I really appreciate how much everyone wants to acknowledge everyone. But especially at larger national meetings, if you've got a 15-minute talk, you can't spend 3 minutes on the acknowledgements, right? So this is just more a tip for balance. Some other tips, answering questions obviously is an important part of this. And so you really want to answer questions as directly, clearly, and concisely as possible. So don't ramble, don't pick another question to answer. People sometimes do this, they don't know the answer and then they divert. That's a political move, but it's not a move that we want to practice as scientists. It is completely 100% okay, and I would actually even argue to encourage to say, I don't know when you don't know. I think that's just a sign of an honest and true scientist. And when you say that and you follow it with, but I'll try to find out, or I'll look into that, then hopefully it's something that actually helps you actually grow. I also think that you want to avoid coming across as defensive. Sometimes you'll see this at conferences, and I think it's always important to show a willingness to engage in discussion. Some other tips in this direction: when it's appropriate, use backup slides, and if your answer is going to be too long in detail, then suggest a follow-up discussion during a break. And maybe just some final notes on how you can improve. I started this by saying that really becoming a better public speaker is an ongoing journey. And so the ultimate goal is to hopefully be able to be yourself, be happy being in front of the audience. And if you're not a happy public speaker, this will take a concerted effort, and you may never be 100% comfortable. Carl Wiechert once told me that you shouldn't be worried about being nervous because it means you care. And throughout your career, you never stop being nervous. It just takes less and less time for the butterflies to settle. And I think that remains true. Some other general tips: don't memorize your talk. That always comes across as far less relatable, but do have a clear logic flow in your head. And if you have certain parts you struggle with, then those are maybe sentences you could write down or think about a bit more. The other big one is to seek feedback from your supervisor, from your peers, and also practice self-assessment. And here, I want to say that seeking feedback doesn't mean, how was my talk, right? Wanting it. And so if you really want feedback, I think it normally helps to approach people with your own self-assessment, right? And so if you start, I think that my introduction worked well, but I thought when I got to the mechanistic aspects, maybe that wasn't as clear as it could be. And then you give someone a place to actually connect to you. If you're just looking for, you were great, then it falls in a category of another one of my coworkers who every time I asked him how his talk went, he said, I brought the house down. It doesn't beg self-assessment, right? So one has to be self-critical and ask these things. The other tip, which I actually hate, but Frank is doing it to me now, is to record your talk, the next part I don't have to do, and watch them to evaluate what you did or didn't like. I always find this torture, which probably means there's more I could do, but I just hate it, so I don't like having to watch recordings of myself. So the other tip is, if you don't want to watch yourself, watch people whose talks you do like. And here I put study the greats. I put two of my favorite speakers, because I think both of the Obamas are absolutely amazing orators for different reasons. Michelle Obama in particular, in her ability to connect to an audience. So even though it's not a scientific talk, the way she manages to bring every person in the room into her talks, I think, is phenomenal. Of course, on the scientific side, when you're looking for scientific inspiration, just pay attention to the people who you saw at recent conferences and symposia. It was fun to get everyone's feedback who went to the Eckerd-Bell Symposium, and it was quite interesting to me that it seemed pretty unanimous what talks people found to be really great talks. And then don't stop at evaluating, oh, that was a great talk, but why was it a great talk? What was it about the way that they outlined their story, the way their slides evolved, the way they interacted with the audience? These are the sort of subtleties that you should take the time to actually know. And you can do the opposite. We've all seen talks that are less good, and Frank tried to give a demonstration of that. But use that information and then use it to self-reflect. And perhaps most importantly, in terms of my advice for giving talks, is do it because you love science and you want to communicate science better. And with that, I think that is all that I had put together for you guys on this topic. And we would be happy to hear your thoughts